Today we're going to be talking about parallel and perpendicular lines. So we're going to start out talking about parallel lines. And so what you need to know about parallel lines is that they do not intersect. So remember that parallel lines are kind of like those train tracks that I'm sure that you remember from elementary or middle school. And so if you have two lines that are parallel, you should know that the slope of each of the lines will be the same. So you should know that the slope is the same. And so even if these lines continued, they would never, ever cross. So when we're determining if the lines are parallel, what we're going to have is two different equations. We're going to look at their m's and compare their m's or their slopes and see if they're the same. If they are the same, then they're parallel. And if they're not the same, then they're not parallel. So remember that we want our equations to be written in y equals mx plus b. So if they're already written in mx plus b, then we're good to go. But if they're not, then we need to make them to where they're written in mx plus b. So in our first equation, we have y equals 3x plus 2. So if we're identifying the m, remember that m is always in front of the x. And so in this case, our m would be 3. In our second equation, we have y equals 3x minus 9. So the number in front of our x would be 3. And so our m would be 3, and since 3 and 3 are the same, then these two lines would be parallel. So if we were to graph these lines on a coordinate plane, they would never ever cross. In our second set of equations, we have y equals 5x plus 8, and so if we look at the m for this one would be 5, because 5 is the number that's in front of x, so it's in the place of m. In our second equation, we have y equals 1/5 x plus 7. So we look at our m, which is 1/5. And when we compare 5 to 1/5, we see that they are not the same number, and so these are not parallel. Here we have y equals 3/4 x minus 7. So our m would be 3/4, the number in front of x. In our second equation, we have y equals 3/4 x plus 1. So our m would be 3/4 on this one as well. So since both of our m's are 3/4, that means that our lines have to be parallel. And the next one we have y equals negative 7x plus 6. So our m would be the number in front of the x, which would be negative 7. In our second equation, we have y equals negative 7x minus 4. Number in front of the x again is negative 7. And since both of our m's or our slopes are negative 7, that means these two lines must be parallel. And then the last one, we have y equals 4x plus 2. So our slope would be 4. In the next equation, we have y equals negative 4x plus 5. So our slope would be negative 4. And since both of our slopes are not the same, one is positive 4, one is negative 4, we would say that these two lines are not parallel. Before we can talk about perpendicular lines, we have to talk about reciprocals. So reciprocals are pretty much just flipped fractions. So some examples would be like 3/4 and 4/3. So 3/4 was the original fraction, and so if I want the reciprocal of that, all I have to do is flip the fraction 3/4 and make it 4/3. Another example would be 1/2 and 2/1. So all I did was flip the fraction 1/2 and make it 2/1. If I had a whole number like 3, the reciprocal for 3, remember I can write 3 as a fraction by putting it over 1. The reciprocal for 3 would be 1/3. And negative reciprocals are pretty similar, so they're still flipped fractions, but you're going to change the sign. So you're going to flip the fraction, and change the sign. So, for example, if I had positive 3/4, the negative reciprocal would be negative 4/3. If I had positive 1/2, the negative reciprocal would be negative 2/1, or just negative 2. If I had positive 3, the negative reciprocal would be negative 1/3. So a negative would turn into a positive would turn into a negative. So if I had an example like negative 5/6, the negative reciprocal would be positive 6/5. So perpendicular lines intersect to form right angles. So these two lines are examples of perpendicular lines because if I were to take a protractor and measure these angles, they would be perfect right angles or 90-degree angles. Their slopes are negative reciprocals. So what would the perpendicular slope be? So if I'm talking about negative reciprocals for a perpendicular slope, if my slope was 2/3, the negative reciprocal or the perpendicular slope to 2/3 would be negative 3/2. If my original slope was 5 and I wanted the perpendicular slope of 5, it would be negative because my original slope was a positive, and then I would flip 5. First I'd put 5/1 so I knew that it was a fraction, and then I would flip 5/1 to be negative 1/5. The negative reciprocal or the perpendicular slope for negative 1/4 would be positive 4/1 or just positive 4. 7 would be 7/1 for the original slope. Perpendicular slope would be negative 1/7. For m equals negative 2, remember I could take that negative 2 and put it over 1 since it wasn't written as a fraction to start with. The perpendicular slope would be positive because it was negative to start with, positive 1/2. And negative 7/8, the perpendicular slope would be positive 8/7. And last, the positive slope 4/5, the negative reciprocal or the perpendicular slope would be negative 5/4. So if line AB has a slope of 2, what is the slope of CD if it is parallel to line AB? So it's important that I pick out the key words here. So it tells me that line AB has a slope of 2. And it asks me, what is the slope of line CD if it's parallel to AB? And so remember that if it's parallel, that means it has to have the same slope. So if the slope of AB equals 2, then the slope of CD would also have to equal 2 in order for them to be parallel. For example 2, if line EF has a slope of negative 1/3, what is the slope of line XY if it is perpendicular to EF? So again, I have to pick out the things that are important. So it's important that line EF has a slope of negative 1/3. And it's important that it's asking me for the slope of XY if it is perpendicular to line EF. So that word perpendicular tells me that my slopes have to be negative reciprocals, which just means flipped fractions that have changed the sign. So if the slope of EF equals negative 1 over 3, and xy is perpendicular to that, then that means that the slope of xy has to be the negative reciprocal of negative 1 over 3. So if EF was negative, xy has to be positive, and EF was 1 over 3, so xy has to be 3 over 1, or positive 3. Number 3, if the line RS has a slope of 5, what is the slope of PQ if it is perpendicular to line RS? So it's important that we're talking about line RS with a slope of 5, and that we want the slope of line PQ if it's perpendicular to line RS. So that word perpendicular tells me that I need negative reciprocals for my slopes. So if the slope of RS is equal to 5, then the slope of PQ has to be the negative reciprocal of 5. Remember that 5 is really 5 over 1, so it would be negative 1 over 5. So all I did was change the sign from positive to negative and take 5 over 1 and flip it to make it 1 over 5. Example 4. If line JK has a slope of negative 7 over 9, what is the slope of MN if it is parallel to JK? So it's important I'm talking about line JK. It has a slope of negative 7 over 9, and I want to know what is the slope of line MN if it's parallel to line JK. That word parallel tells me that my slopes are the same. So if the slope of JK is equal to negative 7 over 9, and MN is parallel to that, then that means the slope of MN is also negative 7 over 9. So when we go to determine if the following lines are parallel, perpendicular, or neither, remember we're always going to be looking at the slope to determine that. So remember that our equations are written, or we hope that they're written, in y equals mx plus b, and if they're not, we need to write them in y equals mx plus b. So our first equation is y equals 3x plus 1. And if I want the slope of that, I have to look at the number in front of the x, which is 3. My second equation would be y equals 3x plus 6. The slope for that would be the number in front of x, which would be 3. So I compare my slopes, 3 and 3. Since they're the same, that means they must be parallel. In the second equation, or second example, I have y equals negative 4x plus 7. My slope is my number in front of x, which is negative 4. My second equation is y equals 1/2 x minus 4. And so my slope for this one would be 1/2 because it's the number in front of x. And I have to determine if they're parallel, perpendicular, or neither. Parallel means that they have the same slope. Negative 4 and 1/2 definitely are not the same. Perpendicular means that they're negative reciprocals. And so if I had negative 4 for my first slope, my second slope would have to be positive 4 over 1. And so since these don't seem to have any relationship, we would say that these two lines are neither parallel nor perpendicular. In number 3, I have y equals 3/4 x plus 1 for my first equation. So my slope would be positive 3 over 4. My second equation would be y equals negative 4 over 3x minus 7. So my slope for that would be negative 4 over 3. In order for these lines to be parallel, they must have the same slope, and so 3/4 and negative 4 over 3 are definitely not the same. For them to be perpendicular, they have to be negative reciprocals. So 3/4 was my first slope. The negative reciprocal of that would be negative 4 over 3. And so since these appear to be negative reciprocal slopes, they must be perpendicular. Example 4, my first equation is y equals x plus 3. My slope is my number in front of x, and so if there's not a number there, I can write in an imaginary 1. So my slope for the first equation would be 1. For my second equation, I have y equals negative x plus 2. My slope is my number in front of x, and remember, if there's not a number there, I can write in a 1. But because I had a negative in front of that x, my slope would be a negative 1. For these two lines to be parallel, they have to have the same slope. 1 and negative 1 are definitely not the same. For them to be perpendicular, they have to be negative reciprocals. So think about 1 as a fraction. If I were to write 1 as a fraction, it would just be 1 over 1. If I were to write negative 1 as a fraction, it would be negative 1 over positive 1. These two appear to be negative reciprocals because they have different signs, but they are flipped versions of each other. So that means that these two lines must be perpendicular. Number 5, my first equation is y equals. For example 5, my first equation would be y equals negative 1/3 x plus 5. My slope would be negative 1 over 3. My second equation would be y equals negative 3x plus 1. So my slope would be negative 3. For these two lines to be parallel, they'd have to have the same slope. Negative 1 over 3 and negative 3 are not the same. For them to be perpendicular, they'd have to be negative reciprocals, which means that they'd have to have opposite signs. Since these two have the same sign, they're both negative, we can say that these two lines must be neither. For number 6, our first equation is 2x plus 5y equals 10, and our second equation is 5x minus 2y equals 12. Now remember, in order for us to easily identify what our slope is, we have to have those equations in y equals mx plus b. So we need to change both of these equations to where they're in that y equals mx plus b form. So with the first equation, I've got 2x plus 5y equals 10. So remember, I'm going to take that 2x and I'm going to jump it over because I'm trying to get y to be by itself. When I jump it over, it becomes negative 2x. So then, since I moved this, it goes away, and I just have 5y equals 10 minus 2x. Then because I'm trying to get y by itself, I'm going to divide both sides by 5, everything in both sides. So I end up with y equals 10 over 5, which is 2, minus 2 over 5x. So now my first equation is going to be y equals 2 minus 2 over 5x. And even though it's not written exactly like y equals mx plus b, we still know what our m is and what our b is easily by just knowing what are the characteristics of m and b. So remember that m is the number in front of x, and so the number directly in front of x would be negative 2 over 5. Now I have to do the same thing that I did for equation 1 for equation 2. So I need to get y by itself on this one. That means I need to take this 5x and jump it over, make it negative 5x. When I jump it over, it's moved from here, so it disappears, and I have negative 2y equals 12 minus 5x. To get y by itself, I need to divide everything by negative 2. When I do that, my negative 2's cancel, and I'm left with y equals 12 divided by negative 2, which is negative 6. Negative 5x divided by negative 2 would be positive 5 over 2x. Remember, negative divided by a negative is a positive. So my second equation would be y equals negative 6 plus 5 over 2x. Remember, to find my slope, that's the number in front of the x. And so in this case, the number directly in front of the x would be 5 over 2. For these two lines to be parallel, they'd have to have the same slope. For them to be perpendicular, they'd have to have different signs and be flipped versions of each other. And so they do have different signs. This one's negative, this one's positive. I have 2 over 5 and 5 over 2, so those are flipped fractions. That means that these two lines must be perpendicular. Number 7, I have 3x minus y equals 6 and negative 3x plus y equals 8. Remember, I need these equations to be in y equals mx plus b. So the first thing I need to do is take this 3x and jump it over and make it negative 3x. When I jump it over, it disappears, so I have negative y equals 6 minus 3x. But remember that we always want our y to be positive. And so if we have a negative, that means we need to divide everything by a negative 1. When we do that, the negatives will cancel. I'm left with y equals 6 divided by negative 1, which would be negative 6, and negative 3x divided by negative 1, which would be positive 3x. So my first equation would be y equals negative 6, plus 3x. And so my slope would be positive 3. For my second equation, I need to take negative 3x to the other side and make it positive 3x. So it disappears from that side on the left side, and I have y equals 8 plus 3x. Since y was already by itself and it was positive, my equation would be y equals 8 plus 3x. So my slope is the number in front of x, which would be positive 3. And since these two lines have the same slope, they both have 3 for their slope, that means these two lines would have to be parallel. For number 8, I do the same thing. I have x minus y equals 10, so I jump x to the other side and make it negative x. So then I have negative y equals 10 minus x. Remember, I need my y to be positive, so I divide everything by a negative 1. Those negative ones will cancel, and I have y equals positive 10 divided by a negative 1, which would be a negative 10. And negative x divided by a negative 1 would be a positive x. So then I have the equation y equals negative 10 plus x. So remember, my slope is the number that's in front of x, and if there's not a number there, it's an imaginary 1. So my slope would be positive 1. For my second equation, I do very similarly the same thing. I take x, jump it over, make it negative x. So I have negative y equals 12 minus x. Divide everything by negative 1 to get rid of the negative. And when I do that, I have y equals positive 12 divided by negative 1 would be negative 12. Negative x divided by negative 1 would be positive x. So my second equation would be y equals negative 12 plus x. Remember, the number in front of x is the slope, and if there's not a number there, it's a 1. So my slope would be 1. Since these two equations have the same slope, they would be parallel. For number 9, I have 2x minus 4y equals 8. Remember, I want these equations to look like y equals mx plus b. So the first thing I'll do is jump this 2x to the other side and make it negative 2x. If I jump it, it moves from this side, so now I'm left with negative 4y equals 8 minus 2x. Because I want y to be by itself, I divide everything by a negative 4. Those cancel, and I'm left with y equals 8 over negative 4, which is negative 2. And negative 2 over negative 2 would be a positive 1 over 2x. Remember, I can take the fraction 2 over 4 and reduce it to 1/2. So my first equation is going to be y equals negative 2 plus 1/2 x. So my slope would be 1/2. For my second equation, I take 2x to the other side because I want y by itself. That gives me negative 3y equals 9 minus 2x. I divide everything by a negative 3 because I want y to be by itself. So I have y equals positive 9 divided by a negative 3, which is a negative 3. Negative 2 divided by a negative 3 is a positive 2 over 3x. So my second equation would be y equals negative 3 plus 2 over 3x. So my slope for the second equation would be the number in front of x, which would be 2 over 3. For these two equations to be parallel, they have to have the same slope. 1/2 and 2/3 are not the same. For them to be perpendicular, they have to have negative reciprocals. 1/2 and 2 over 3 are not negative reciprocals. So they appear to have no relationship, so they have neither parallel nor perpendicular slopes. For number 10, I need to get x or y by itself, so I take x and jump it to the other side, so it becomes negative x. So then I have negative 6y equals 7 minus x. Divide everything by negative 6. The negative 6's will cancel, and I have y equals negative 7 over 6. Remember, with fractions, if it's negative on the bottom, I can pull that negative to the top, and I didn't change anything about what I had. When I have negative x divided by a negative 6, remember, negative divided by negative is a positive. There's an imaginary 1 in front of that x. So I really have positive 1 over 6x. So my first equation would be y equals negative 7 over 6 plus 1 over 6x. So my slope would be 1 over 6. For my second equation, I take 6x to the other side because I want to have y by itself. So when I do that, I'm left with negative y equals 3 minus 6x. Then I want to have this is a positive y. So I've got to divide everything by a negative 1 to get rid of the negative. When I do that, I have y equals positive 3 divided by negative 1 would be negative 3. Negative 6x divided by negative 1 would be positive 6x. So my second equation would be y equals negative 3 plus 6x. So my slope for the second equation would be x. Remember, for them to be parallel, they have to have the same slope. These are not the same. For them to be perpendicular, they have to be negative reciprocals, which means that they would have to have different signs. So we've got positive 1/6 and a positive 6. So since they are not different signs, even though they are reciprocals, they have to be negative reciprocals to be perpendicular. So because they don't have different signs, these are neither.